So today I'll be talking to you about something called an arithmetic series. So this is different than an arithmetic sequence, which you saw in one of the previous videos. In an arithmetic sequence, again, in a simple sense, the difference between a sequence and a series is that a sequence is just a list of numbers that are separated by commas, and a series is a list of numbers that are being added together. So some people would say that it's like a sequence where the commas are all pluses instead. And that's close. Really, what it's about is this idea that a series just has things added together. You're looking at adding together the terms in a sequence instead of just listing them out. So the first thing that I want you to do is I want you to recall what the notation UN means. So think about that for just a second and remember what U sub n means in a sequence. So hopefully you remember that U sub n just represents the nth term in a sequence. So U3 means the third term, U17 means the 17th term. Yay, fantastic. So today we're getting a new notation, and that notation is S sub n, so capital S sub n. Right? And this thing is the nth partial sum of the sequence or the series, which means it's the sum of the first n terms, and I'll write that out. So for instance, if someone were to ask you to find S3, it would mean you need to take the first term plus the second term plus the third term. And so you can see where people get this idea that, oh, a series is like a sequence where instead of having commas, you have pluses in between. Okay? I mean, it goes without saying that if someone were to ask you to find S17, it would mean U1 plus U2 plus, all the way on up to U17. Eventually, we're going to get formulas for these things. I'm not going to give you formulas in this video because I sort of want to play around just with this concept and making sure that we understand the notation and what that means. So don't expect any formulas in this one. We're really just working with the idea that Sn means the sum of the first n terms. So I've got two examples that we'll look at. So this first example, I want us to consider an arithmetic series for which S1 equals 5, S2 equals 7, and S3 equals 6. I want us to find the values of U1, U2, and U3, and the common difference. I'd love for you guys to sort of pause the video and figure out as much of this as you can on your own. At the very least, stop the video for a second and think about what U1 would be. See if you can figure out what the first term of the sequence would be if these three things here are what they are. So the idea is, think about what S1 means. S1 means the sum of the first 1 terms. So if I add up all the first 1 terms together, I get 5. So doesn't that mean that U1, does that mean that the first term has to be 5? Right? Now that we've said that, again, pause the video and think for a second. Can you figure out what U2 would be now that you know that the first term has to be 5? Well, I hope that you paused the video. I hope that you thought about that. I hope that you recognize that S2 has to be the first term plus the second term. In other words, 7 has to be equal to 5 plus whatever the second term is. And so from here, we can tell that the second term has to be 2. Right? Following along with that idea, we can sort of see that, okay, what about U3? Well, the sum of the first 3 terms has to be U1 plus U2 plus U3. So that means 6 has to be equal to 5, which we figured out from here, 2, which we figured out from here, and the third term. If we solve that, we'll see that the third term is -1. Right? Now, what about the common difference? Right? Is there a common difference here? Well, if there was a common difference, we'd be able to see it. Right? Sure enough, it looks like the common difference is -3. Because if I take 5 and add -3 to it, I'll get 2. If I take 2 and add -3 to it, I'll get -1. So this was a problem where we didn't use formulas at all, we didn't use any fancy stuff, we just used our understanding of the notation and things to sort of understand what the numbers in this problem were going to be. So for the last example that I have, I'm going to tell you that the first term in the sequence is -3, the common difference is 2, and I want to know what S5 is. Right? Well, how are we going to find S5? I mean, what is S5? Think for a moment, what does S5 mean? And hopefully you recognize S5 means the sum of the first 5 terms. In other words, S5 means U1 plus U2, U3, U4, and U5, right? So, I mean, we know what the first one of those terms is. Do I know what the other ones are? I suppose not yet, but if we know the common difference is 2, we know that the first term is -3, the second term is, add 2 to that, -1, the third term is 1, the fourth term is +3, and the fifth term is 5. So that means S5 is -3 plus -1 plus 1 plus 3 plus 5. And in this problem I sort of specifically constructed it so that a nice thing would happen. Notice that when you add -3 and +3 together you get 0. When you add -1 and 1 together you get 0. And so when all is said and done, our answer is that S5 is equal to just that last term of 5. Okay. So again, some of the problems you're going to see on the IB exam, some of the things that you're going to see whenever you do these problems are things where it doesn't necessarily make sense to use a formula, where you can just reason through where they are. Where the formulas really come into play is when we have larger numbers, when we've got wackier things happening. And so you'll see that the next video is going to be about that. So I'll see you there.